We're going to take a look at perfect square trinomials. We have x squared plus 6x plus 9. What are some factors of 9 that when we add them together give us our b term of 6? 3 and 3. Very good. That way we'd have x plus 3 times x plus 3. We can check this out. If we were to have x plus 3 here and x plus 3 here, that would give us x squared. X times 3 is 3x. X times 3 is 3x here. And then 3 times 3 is positive 9. When we write this out, we end up with x squared plus 3x plus 3x plus 9. We now see that this is going to be, after combining like terms, x squared plus 6x plus 9. Alright, this is a perfect square trinomial because you can see there we have two binomials here that are exactly the same. X plus 3 times itself. What happens when we multiply a number times itself or anything by itself? We're squaring it. So we have to square this binomial. X plus 3 is a binomial. So it says a perfect square trinomial is created when you square a binomial. As we continue with recognizing perfect squares, we're going to see that there's a general pattern that we can end up in the end doing a squared plus doubling the product of a and b, and then plus your b value squared as well. When we have a binomial that's being subtracted and squared, so we have the binomial there with subtraction and it's being squared, you're going to end up with negative 2ab in the middle. And then when you have both terms inside the both terms of the binomial positive, you're going to end up with a positive middle term or b term. All right, let's continue on to practicing. 16x squared plus 88x plus 11. Let's take a look here. Is 16x squared a perfect square? I know that 4 times 4 gives me 16, and x times x gives me x squared, so 4x and 4x gives me 16x squared. For 121, we take a look at a number times itself to give us 121. That's going to be 11. So we end up with 4x plus 11 times 4x plus 11. If this gives us our original trinomial, then that means this is a perfect square trinomial because it is the result of a binomial being squared. Alright, so here we have 4x times 4x, which is 16x squared. I then have 4x times 11, which is 44x. I then have 11 times 4x, which is 44x. And finally, we have plus 121 here after multiplying 11 times 11. 44x plus 44x is 88x. So we now have here 16x squared plus 88x plus 121. Is this a perfect square trinomial? Yes, it is, because when we factor, we end up with 4x plus 11 squared to give us 16x squared plus 88x plus 121. Moving on now, let's see if this is a perfect square trinomial. And then, actually it is, and then what we want to do is actually solve for 0. So what times what gives us 25? That when we add it together gives us negative 10. Negative 5 times negative 5 is positive 25, but negative 5 plus negative 5 is negative 10. For q, we know that we're going to have q and q. So here we can write out q minus 5 times q minus 5. And remember, this is going to be equal to 0. Alright, but let's go back and check this out just to be on the safe side to be sure it works out. We would get q squared minus 5q minus 5q plus 25, which is q squared minus 10q plus 25. So it does work. So now we set this equal to 0, each of them. Q minus 5 equals 0, and q minus 5 equals 0. We know that when we want to solve these, we use inverse operations. So we have to add 5 to both sides. When we add 5 to both sides, we end up with q is equal to 5 here, and we end up with q is equal to 5 here. So we see that the solutions for both are identical, so we don't need to write 5 and 5. We only write 5 once for our final answer here for number 2. Q is equal to 5.